Welcome to T2 Day 25 of Calculus. Today we're going to circle back a little bit to related rates. And what we have here is a cone that is emptying out into a cylinder. And there's a bunch of information in this paragraph that we're going to pull apart piece by piece. The first part says, write an expression for the volume of water in the conical tank as a function of h. So we know that the volume of a cone is 1/3 pi r squared times h. And that right there is not quite what it's asking for. It's asking for an expression that represents the volume of water in the conical tank as a function of h, meaning only h, a function of h. So the key here, and it's something we've done before, is we've related with a radius and h. So what do we know here? We have this triangle here, and we know that 12 is to the radius. So 12 is to the radius of 4. Key is the radius of 4. So we know that the height is to the radius as 12 is to 4. So height to radius is going to be 12 to 4. So that tells us that 4h is equal to 12r. So therefore, we need to get rid of the r, so we need to solve for r. So r is going to be equal to 4 over 12 times h. So r is equal to 1 over 3 times h. So what we're going to do is we're then going to take this, march it down all the way to there. So we're putting it in for r right there. So what do we now have? We have the volume is equal to 1/3 pi times 1/3 h squared times h. And I would like you to simplify this a little bit. So the 1/3 is squared, and so is the h right there. They're both being squared, and then you have a third, 1/3 right there. So that's going to end up being volume is pi over 3 times 3 times 3 is 27 times h cubed. So that is the volume of water in the conical tank as a function of h. At what rate is the volume of water in the conical tank changing when h is 3? So we need to take the derivative of our volume function right here. So our volume function v prime in terms of h, that pi over 27 is just along for the ride. You bring the 3 down from the front, and then you have h squared times dh dt. dh dt. And we're doing the derivative with respect to time, so another way we could write this is dv dt. And what are we trying to find? At what rate is the volume of water in the conical tank changing? So we're trying to find that. So therefore, we need to plug in values for h and dh dt. So the way we're going to do that is it's telling us when h is 3. So that right there is 3. The next part is trying to find dh dt, and that's going to come from this right here. The depth h in feet of the water in the conical tank is changing at a rate of h minus 12. That means that dh dt, to put it another way, is h minus 12. So the rate of change of the height is h minus 12. So when h is 3, so what is dh dt when h is 3? And that's from the green highlight above. That's going to be 3 minus 12 is -9. So this -9 is going to get plugged in right there. So what do you end up with? dv dt is equal to pi over 27 times 3 times 3 squared times -9. And you have to do a bunch of canceling. And what's nice is that this is 27 and that's 27. That cancels, leaving you with -9 pi. And that's going to be a change of volume, so that's feet cubed per minute right there. The next question asks, let y be the depth in feet of the water in the cylindrical tank. At what rate is y changing when h is 3? So at this moment, it's the same moment right here when h is 3. So what we need to do is write an equation. But even before that, let's draw a picture again. So we have our cylindrical tank, and what does it tell us? It tells us the base from the problem. It tells us the base has an area of 400 pi square feet. So we know that this area right here is 400 pi feet squared. So we have the water, it's being filled up here. Here's our water, right? Here's our water level. You like my drawing right there? Water's filled up all the way to there. Let y be the depth. So this distance right here is y. So what is the volume of that water? The volume of that water is pi r squared times h. The volume of a cylinder is pi r squared times h. But in this case, we're not calling it h, we're calling it y. And it says at what rate is y changing when h is 3? Well, r in this case is going to stay the same because it's a cylinder. And we can find out what r is based on this. The area of a circle is pi r squared. And we know that pi r squared is going to be 400 pi from here. So we know that r squared is equal to 400. So r is going to be 20. And we can substitute this in right now because r isn't changing the entire time. A cylinder has a constant radius. So it's pi times 20 squared times y. So what do we have here? We have v equals 400 pi times y. So now it says, go back and look at what we're trying to find. At what rate is y changing when h is 3? So we should have started this way. I'm violating my own rules here, not saying no one want. So we want dy dt when h is equal to 3. Well, let's take the derivative. We end up with dv dt is equal to 400 pi times dy dt. And we're trying to solve for dy dt, so the only unknown we now have is this dv dt. Well, when h is 3, do we know dv dt? We do, it's right here, it's negative 9 pi. So you know that this is negative 9 pi equals, not 900, if I can write that properly, it's going to be 400, remember we got this from the last part, 400 pi dy dt. So that tells us that dy dt, and the pi's are going to cancel, are going to equal to negative 9 over 400, and this is change in height, so it's going to be feet per minute. So we've linked together several related rates here. Take it slowly, write in what you know and want, substitute when you can, and